So, geht's jetzt endlich? YouTube? Aha! Aha! Okay. Super. Was ist denn das für eine Scheiße? Warum habe ich jetzt eine Notification bekommen? Er schickt mir eine Notification, dass ich live auf meinem eigenen Kanal bin. Okay, Bro. Weird, aber sure. Also, ich weiß nicht, ob ich das verstehen muss, aber... Naja. Oh wait, jetzt erlaubt er nur... Ja, Digga, ich verwirre mich nochmal neu. So eine Scheiße. Ich dachte, der supportet vielleicht nur 100p, aber nein. Natürlich nicht. Ja. Dann nochmal. Okay. Aha. Wir sind zurück. Diesmal hoffentlich mit 1080p. Nee. Okay. Ja. Geht hier 1080p? Auch nicht. Okay. Ich hab's eigentlich gerade umgestellt. Aber whatever. Und warum ist meine Cam schon wieder weg? Dankeschön. Ach, YouTube. Digga, da ist wirklich wieder heute... Keine Ahnung, was hier los ist. Okay. Wir wollen alles sehen? Ja. Boah, Voice Chat. Ja. Das ist ein Projekt. Und ich habe eigentlich keine Lust darauf. Aber wir machen das jetzt. We'll do it now. Why am I talking German? We're supposed to be talking English on this channel. So I guess we'll do that. God dang it. Alright. Is my audio like really good? Why is it not? Alright, the music is that silent. Okay, then we'll just leave it at that. I suppose. That works. Okay. I just needed a motivation to work on this thing, so this will be that now. And just so I can see if it works, I have my camera. That's nice. Dude, the delay is insane. Holy shit. Oh, that's top. I'm gonna go to the bottom. Yeah, I have it bound to minus and plus. Don't question it, but get the point. Alright. We're gonna have to make a player now. And that, preferably, give me a second. Oh, it's just showing the bar again. It's cool. That's very cool. It's just showing it for no reason at all. Okay. Can I drag you? That would not be a good idea, I think. Because there's a lot of weird stuff here. I'll just do it like this, maybe? I think that's fine, yeah. Alright. What you doing? Oh, what is this? Oh, now we're starting... Oh, it's playing the full thing. Okay. I don't think I want this in here though. We're gonna skip that one. So yeah. This library looked good, so we're gonna try it out. Is this just a packet implementation? Huh? Okay, I'm gonna have to see how this... What? Huh? Why's your GitHub repo not working? But the thing's still on? Okay. It's been downloaded a bunch too. She has a lot of packages. What the hell? Maybe she renamed Hum Systems? Maybe she just renamed it? Oh yeah, it's been renamed. And it lies here now. Okay. Well, I guess we can use it. Because why the hell not? And this, maybe closing. Alright. We're just gonna edit. Because why the frick not? So, yeah, I hope this doesn't drag down any versions. Wait, every time I press enter, it's gonna... No, that's not what I want. Let's change it. It'll be comma now. That's not gonna... Right, so now it should be there. Hello? Yes. If I press comma, it's gone. I have to press plus again, we're here. Press comma on the normal keyboard. Nice. Okay. Okay, good. God dang it, YouTube. Anyways. So, still having fun about how we're gonna make this player work. I've got some ideas. And just have the music be a little bit more silent. So we of course need clients, right? Some kind of client is going to be needed. Like similar to how I did it here in the decoder. Actually, let's first experiment with the jitter library a little bit and see what it can do. Just gonna print this out real quick. And let's see how this works again. So, yeah, we don't need an RTP stream. So jitter buffer. Yeah. So just before I do anything. Yeah, it's literally one class, okay. And what did you use? Time and collections. Yeah, okay. That seems reasonable. Doesn't seem like there's any shitcode in here. Futures timer, log. Well, I mean, yeah. Doesn't really seem like there's anything that would like do weird stuff here. So I assume we can say that this crate is safe. I didn't check it like 100%, but it seems safe. So we're gonna roll with it. Alright, jitter buffer new. Okay, this one's a packet. So we need some kind of implementation, I suppose. Like what they have. GitHub. Wait, let's find it again. This one. What is this? Oh, it's protobuf. Okay. Also for engineer. Thanks for your work. Okay, so we're just gonna need like a struct like packet or something. Or let's just call this opus packet or something, whatever. And then you will, I don't know what this contains yet. And we're gonna, supposed to implement this. Oh yes, it's supposed to be jitter packet. Okay, so it just needs, oh, okay. Okay, we can do that, yeah. Sure. Sure. Okay. So you're gonna need a sequence number. So for now, we're just gonna like make one here maybe. Isn't U16? How did you do this again? God dang it. I like this JavaScript. It's like, I feel like this may be a little bit. How many packets does this mean we can send? Sequence numbers. Like 16-bit integer limit. Dude, this is a little bit. This is cutting it close a little bit, I feel. With. I'm not comfortable with that. Unsigned. You know what, actually I'm gonna use, it's not much better. Just gonna browse the internet on my second screen. Well, that's 60k, which is not great. Why would you choose this? This is not nice. This is a weird technical limitation, I guess. Not technical limitation, but 32 packets, if we send 50 every second. That means we can only send for 1,300 seconds. That's not a good idea. Do we just fork the heck out of this thing? Guess we gotta. Well, I suppose there's nothing we can really do about it. Because we want longer packet numbers. That's already pretty certain. We definitely want those longer packet numbers. Like, we want them long, you know? I mean, I would go for like a U64 to be honest. Or 32 is probably fine either way, but can we just return a U32 here? Does that work somehow? Okay. Yeah, no, it wants a U16. Which just doesn't make a whole lot of sense. sadly. I guess it would be a good idea to just fork it, maybe. This thing's pretty long and it has tests too. Preserves normal ordering when not encountering wrapping. Wait, does this like wrap? Well, if it does that, then that's fine. I guess it won't matter. Oh! Okay, I get it now. I get it now. So we're supposed to like... Yeah, okay. Okay, got it. So if this is over the limit, we're supposed to just like wrap it probably. So we can try that out real quick. And create one with our Opus packet, and then we'll say 10 maybe. The trade bound satisfy the trade clone is not implement. Okay. Then we'll need derive, cargo add derive. It's called derive, right? Cargo remove derive. Never mind. What's that thing called then? Derive clone thing rest. Oh, okay, this is not a library. Never mind then. I thought this was a library. Okay, that's nice then. Okay. I swear I thought this was a library, dude. I don't know why I thought that, but... You know. Guess it's in the standard library, which would make more sense. So... Then here we'll just like return self.sec. I'll just be like that. And this is how many we want it to use. It's also kind of weird that you have to specify this in the type. But yeah, I guess I get it. I do get it, but not that great. Anyways, so can we just say buffer? And then this wants us to just give me a second. Jitter. You want me to also make this mutable, and then they make an interval here. Interval. It's from Tokyo. Duration from millis. We'll use 20. And then we have a select here. And requires at least one branch. Yeah, that's what I'm doing right now. Next, dot fuse. Okay, this is playback button. Tick completes the when the next instant in the interval has been reached. Full tick. Mystic behavior. Okay. So here we can just do like an interval. Dot tick. Oh wait, dot tick. Huh? Oh wait, playback dot tick. Oh wait. Oh, so this is when we get something back, we can like... Okay. How does this work? Tokyo select. Yeah, I know that. Give me a code example. Okay. This is equal to playback.tick. Oh. Okay, that's useful. And now all I will have to do, I mean, we only need this, so it doesn't really matter, but in the player we could now have like another one that like listens for the receiver and adds it to the thing, which would be kind of useful, you know. And so here we just say like packet equals buffer dot unexpected token tree. I do not care. Now you're not saying it, huh? Why does it? Whatever. Yeah, and then we could like say now playing, and then we'll just say like, let's say we'll put the sequence number here, so packet.sequence, I think. Oh, yeah, right. Oh, but we have the sequence number from. Oh wait, no, that's private. We'll just make this public. Whatever. Oh, we can just grab it like this, I think. Oh, and it is an option type, so we're gonna say. So I assume this is just also handling drop packets for us, which is really cool, by the way. So it's just gonna handle drop packets for us as well. That's really nice. When it pops, I assume we're going one in the queue, and it's like, oh, I didn't see that. We have like a buffer.last? No, probably not, but we could do that ourselves. No problem. So the question is, when we pop it, what do we do with it? So for now, well, we can say if packet is none. Then we will just, for now, just return maybe. Or say like, failure. And here we'll say, now playing. No, don't do this. And then here we'll packet it unwrap. And here we can grab it. Okay. So in this we'll just say playback.tick. Oh wait, we'll do it like this for now. Roger just entered the room, so we couldn't. Now we should be back. Alright, nice. Good. Alright, so I just added this loop here, which is hopefully gonna start playing those. I hope. And then I guess we're gonna now have to look it with a mutex and an arc. We're just gonna do this. As well. And this thing. That's fine. Here we're gonna need the Tokyo mutex. And then here we'll grab the buffer first. So buffer the wait. For the lock. And .await, .unwrap. So this is that, yes, and then we wanna have this mutable like this. Okay, nice. And then in here we're gonna have another loop, and we're gonna say, or rather, I do not have a loop here. We're just gonna always, let's just do something like this, and then just so we can like try this out, and then push. Then here we could add an opus packet with 1. And then here, before we go into this closure and move it, we're also gonna make a different scope. We're gonna just clone this thing here, and this doesn't need to be mutable. Okay. So, if everything works like it should, we're gonna do a quick like time sleep, and then we're gonna say duration for millis, and we're gonna do like 10 maybe, and then we're gonna do an await. And now if I run this, yes. Okay, that's how we expected it to go. It said now playing 1. And then the rest is just failure. Why? Because that's how we did it. But now let's change the interval up here to 500. Because we just want, you know, for now this can be 500. Because I literally just needed to need to test it out a little bit. So we're gonna add 1, and we're also gonna add 3, and we're gonna see what happens. Okay, that's nice. So it recognized it as a failure, and then after that it did 3. So that means the question is, what if I add 2 here? Okay, that works too. Nice. So then if I add, let's just say we add like a lot of freeze. I want to see what happens. Okay, it's still keeping those around, surprisingly. Why are you keeping those around? You're only supposed to be keeping 8 around, right? Let's do a lot more. Okay, it's still keeping them around. For whatever reason. Because it probably expects us to not be spamming. Well, I mean, if we're getting spam packets, then that's... We'd need to handle that separately anyways. So we're only expecting them every 30 seconds. You'd need to have some kind of system that like says, okay, so how, I mean, I guess I can just slap this at the real-time stream and just see what happens, right? Or we could just use it and see what happens, and if it doesn't work, we can still modify it. Guess that's probably the best option. Because, like, it seems to do a good job. But my question is just like, what happens if we have like a lot of freeze here? And then we get a 5. This is just like for reference, right? Wait, it's probably not gonna... It's probably detecting that those are doubles, and then... It's just probably not that as stupid as I think it is. Let's throw 7, 8, 9, 10, 11, 12, 14 at it and see what happens. Okay, yeah. Okay, good. Good. Yes, this is what we like. Because we want it to play from the last 8 packets. Meaning that if we add any before, it's just gonna continue with those last ones. I just skip a bunch. So that means if we like get spam packets because someone was like lagging or something, which we shouldn't be in the first place, but you know, can happen, then this also makes sure that they're not played in a weird way. And it also ensures this failure. This is a really nice jitter buffer. This is really, really nice. It's a really nice implementation of a jitter buffer. And that means we don't have to do anything here, which I am very glad about, which I find very, very cool. So now the question is just, how do we turn this into a player? I guess that's actually quite simple, to be fair. We can now just like create one of those per client. So we'll have like a buffer here, which is going to be a jitter buffer. And well, it's going to need some kind of packet implementation. So we're going to say like audio packet, which for us is just going to be Opus, but it's already decoded, so it doesn't matter. And I don't need a struct there. And then this will just have the PCM in here. We'll have PCM like a vec f32, and then it can also, like, I'm just using vectors here because that's easier. And then we'd also want, well, so kind of other stuff in here, like the sequence number. Oh wait, yeah, right, I wanted to test that. Alright, so before we start messing around with this, there's one more thing we gotta test. That's like when I put U16 max. Yes, okay. So if we put this, okay, and then after that, we start from those, what will it do? Oh yeah, okay. But it has one failure in between. So, can we go one higher? Oh, it's probably... I see what you're doing. Forgot to include 0. Yeah, okay. Yeah, I get it now. Dude, this is such a smart way to handle sequence numbers. Why didn't I think about this before? I would have just incremented it until infinity. God dang it. But yeah, that's a nice way of handling it. I get it now. So, the question now is just... Yeah, I guess we're gonna have to implement this into our sender as well. So the encoder here, or our packetizer... Well, this for now just encodes the output anyways and just sends it back. This is gonna have to, like, encode it to some kind of packet format. And then this packet is what we turn into some other format and recode into this packet. And we should probably define what this packet is here. so that we don't have issues, because our decoder already has decode data. But at best, this would just be like a packet. I mean, of course it's gonna need extra stuff, but I assume if we have just a packet in here as a vector, and then also the client ID is just not gonna get encrypted into the, or like encoded into the packet, but we're gonna need it anyways. So we might as well also stick it in there. And we'll just use this as a baseline in the engine here, and then we'll say, so we'll just, I'm gonna put this below. I'm gonna make like a packet, like an Opus, let's say Opus packet, or audio packet. Oh, let's say packet. No, that's gonna collide wire packet. Packet. I hate naming things. We'll just say audio packet. I think that does it. That describes it pretty well. Of course, the ID is not gonna be encoded into the actual audio packet, but that doesn't matter, because we're just gonna like implement those things later. So we're gonna have a sequence number that's a U16, and then, well, the packet data, and we're also going to have, do we need anything else actually? I think we do. Sample rate and stuff, probably, right? Sample rate would be good. Is it U32? I think it is. And then frame size, we can calculate that from the sample rate because we know the packet duration, because that's consistent. And because like this divided by 50 is gonna give us the frame size that we want to use. And so this is how we are going to encode it. Okay, and then we implement our packet from jitter for audio packet. And that's just gonna, also we have to derive clone here again, because that's gonna be needed for that. And we should mention this here, that's jitter. And then sequence number is what we're gonna have to implement, and then that's just gonna return self.sequence. Okay, cool. And can we make this public? Nope, we can't. But we're just gonna make all the contents public anyways, because this is something we're gonna have to access in various different other locations, and I don't want to make getters and setters for that because it's just annoying. And so with that implemented, we can now, well, we can get rid of this because I just specified it straight away. And then in our decoder, we want to be receiving, well, packets, and that's going to be audio packet. And you're just going to import this from super. Yeah, that's good. And then this is audio packet. And, well, it just works like that, surprisingly. I mean, yeah, it's all the same stuff. We need like a check here as well, like what to do. Add a check. Make sure to create a new decoder in case the sample rate doesn't match. We're gonna have like an if data dot sample rate is equal to, oh, we're getting that there, so it makes sense to do this here. Decoder get sample. Oh, there's an error with that. We're just gonna get sample rate. Like if this throws an error, then we're gonna have an issue anyways. So we're gonna do it like this. And just put a to do in here. But yeah, for now we're just not gonna worry about it. I'm just gonna hope it doesn't happen We're like, for now we know that it doesn't happen because we're in a tested environment. Didn't even do resampling yet, so we're gonna be, this is like an MVP of the MVPs. And so for the coder, we can just leave it. But the encoder is gonna have a different job now. Yeah, this is something we can work on as well at some point. And so the encoder is gonna need to like package this to the packet. And so we're gonna need some kind of options in here. Like this has the engine.lock. But we're gonna need a sequence number in here, which is gonna be U16. Or let's call it current sec, because we're already using that all over the place. And here current sec. And it's a good idea to randomize this as well, because if it's end-to-end encrypted, or like if we're in an end-to-end encrypted environment, we want some kind of randomization here, because otherwise this is gonna ruin our lives. So let's ask Claude, or Copilot, yeah, Claude in this case. How do I randomize if I get a random U16? Let's hope this guy knows. Dude, this is not what you're supposed to do. No. Get a random U16. Range is 0 to max. Come on. Claude. Okay. Does this work? Random U16. Is there a rand package? It's not even a thing, dude. Alright, random U16 rest. Generate random values. There is an RNG package. RNG. Rand. Threads. Huh? There's a package? It is a crate. Okay. I guess we gotta add it. Cargo add rand. There we go. And rand is gonna rand. Yeah, okay, no. Rand, RNG. Oh, friend RNG. Okay. And random. Does it just... Oh, it just uses the type. That's cool. Because this, like, you know, this has a generic type, so... Through the fact that we're here, that this knows that this is a U16, it just automatically does something random. This is like a secure algorithm. So like rand crypto RNG random. So like random value. This function is short and yes. I would need something more secure though. I want a secure random algorithm. What's within a range? Random numbers within just no. Random number generator. Safe random numbers. Rest. Yes, OSRNG doesn't return, but okay, so we're just gonna do like and we're gonna say crypto RNG new. And crypto. The functions. How do you use this thing? Really unpredictable. Yes. Yeah. Default. Default. Mm. I guess it doesn't have to be that secure. I don't care. I'm not gonna use another crate now. Just cause... Whatever. So we're just gonna say like... Here, this is engine. We're gonna need a mutable here, and then we're gonna say engine.currentsec++. Oh, fuck you. Okay, and then... Well, encoded sender. The sender is also gonna have to send new things now. It's gonna have to send an audio packet, because that's what we use now. And then here this does encoded sender, blocking send, and then create an audio packet here. And the ID, actually we're just gonna make it option, because well, here we're gonna need it, but that's only on the decoding side. So we're just gonna be like data.id.unwrap. Let's find ID. Data.id.unwrap. We're just gonna use that here. Like this. Okay, perfect. And we're gonna here say expect no client ID in decode in packet for decoding. Decode this or something. Yeah, and then here I was gonna say we're gonna say ID none. Then packet is gonna be, well, our packet to Beck. And then sample rate. Do we have something for this? Engine. Let's sample. But we should have the sample rate somewhere. We have an encoder. An encoder to get. Oh, this doesn't give us the sample rate. God dang it. But it should have it somewhere. We have sample rate up there. Sample rate. And then sec is gonna be engine.currentsec. Should work, and then this and dot okay. No issues. Nice. And we don't want this guy. And so this should be fine. So now this one's gonna be, of course, in trouble, but I don't care about this because this is temporary testing code. And with that, the new kind of like architecture is kind of completed. Now we just need a player. Oh, we already created that before. Right. And then we don't want the audio packet here. We already defined that before. But this one, actually we can kind of copy this from here. Right there, so playing engine is going to do this, and this is going to have a hash map. And here for the decoder, we're not going to have anything like that. We're going to have just a buffer, jitter buffer. Actually, we could have it so The decoder writes directly into the jitter buffer, but I feel like that might actually be a better... I don't know if that's a good idea. No. Let's keep it like this. So it just sends out audio packets. And here we're gonna handle this under the hood. This is gonna be audio packet and 8. And... well... for now, nothing else. Oh yeah, client. And... well... we're gonna put this... actually we're gonna leave it here. Implement playing engine. And this is gonna have a called create function again. What this is gonna return, I don't know yet. This. And then we can just like copy these over like this, straight into here. Add a new client to the playing engine, and then we don't need a decoder. We will not need the sample rate because that's in the packet itself. We will just need we actually don't even need a receiver at all here. It's just gonna be an add target and with an ID. And I guess. Oh yeah, right. We want to sync it here, right? Sync. Maybe like that, and then create a new sync for the thing. And this is also gonna maybe need a output stream. Output stream. How do we do this here? Main RS, not there. This has output stream try default, and we create the sync on the handle. So we need an output stream handle here. Output stream handle. And so this becomes a client. And here for sync, we're gonna say sync try new, and then we select that stream. And output stream. Let's actually call this output handle maybe. So it's not too long, but it also refers to what it is. And try new is gonna return us a bunch of stuff. Expect couldn't create sync. And then there's gonna be a sync, so we can pass this one into there already. Sync. And now this just leaves us with a few things we need. So we don't need a sender here. We're just gonna need a buffer. So let's create that one. Also do this straight in here. Buffer, jitter, buffer, yeah. And that should do it. And then we don't return a receiver. We're just gonna leave it like this. And this is gonna be a client. And that does it. Okay. This is progress. And now I should maybe stream more often, just for being more productive, because it keeps you focusing on the code. Because like this, I don't just go outside and just do a bunch of other random crap. I stick to coding. That's the most important part here. Oh wait, what are we doing, dude? We're playing other stuff that's copyrighted. God dang it. God dang it, YouTube Music. No autoplay. I hope we didn't get any copyrighted shit. Well, if I'm gonna get a strike, I can take this off anyways. I was just wondering. Okay. We're gonna need new stuff. Let client equals arc new. This is also gonna new mutex. Self. Actually, we're gonna need a craft and other stuff first. So let's create the output stream for playing the audio. This is kind of important, you know, because we need to actually, you know, play the audio. The only question I'm kind of asking myself is what happens when we... I hope that the stream thing does have like a... Please tell me you have like a change audio device thing, because otherwise we're gonna be in a pretty big issue. We're gonna have some pretty big issues, so stream dot... This isn't having much. Stream handle. Nope. Stream handle dot... Play once, play raw. Into... Okay. Seems like we're gonna have a problem. So at some point, if we want to change the device, we're gonna have to regenerate all the things. God dang it. Well, that's gonna be part of the jam. Regenerating 100 things. Oh god. This is like a classic suck it. We're also gonna have to see how we handle this now, because we're gonna need a bunch of different tickers. Dude, it would just be easiest to just do this in the add target method, would it not be? Just do it there. And if the sync is null somehow, just gonna throw it out or something. I mean, we have the mutex lock on the... I don't know. I'm strongly leaning towards just... I don't know. What do we do here? I mean, we could like... We could anytime just... Well, let's write a creator first, but I don't know if we're gonna need the arc mutex in the end. Because what I'm thinking right now is we could just like do this in a way where the clients have an arc mutex and we just put them into like an async Tokyo thing here, and that thing can just handle most of the stuff. I feel like that's gonna be the easiest solution. But then once when I add like device changing and stuff, it may be a little bit shitty. But yeah, whatever. I'm sure that's fine. You can just use a select hook and maybe do it that way. It could work. For now, we don't worry about changing the device, because problem for future Julian. He's gonna have a lot of fun with it, I'm sure. Alright, so then, well, for now, let's just return a playing engine. And so this is just gonna be literally like return self. And then, I mean, here we're gonna mount it into the if we want to move it. Well, I guess we would move the client, so then the hash map would change and it doesn't impact you too much. You can still return a playing engine. Stream output. Stream handle. Oh, that's not the client map. This is gonna be hash map. Hash map new. God dang it. And then this is the stream handle. And I hope that it isn't like the other ones where if this goes out of scope, then Wait, it might be. Shit. Do we just spawn something to move this into? God dang it. Well, let's repair this real quick and let's try it. Coded sample dot unwrap dot packet. Let's do it like this. And now this is already fixed. So we're gonna just go into main RS. We're just gonna maybe uncomment this garbage. And then let's also create a new engine. And so this is just a little bit of testing. Oh, cargo 1. Hello, what's up? Oh, it's live. Right, I forgot about that. Yeah, this basically just tests the decoding and stuff. So you're gonna have to resist hearing me twice, but I'm gonna have to resist that too, and it sucks. But yeah, so the point is, we're gonna use this here. Or let's do this. We're just gonna, you know, ignore it. Yeah. Okay. Yeah. So this needs to be in scope. I mean, we could just create multiple output streams, but that's also shit. How do we best do this? I don't know what's the best way here. I really don't. We just create new audio streams for every single one. I mean, we can create a new sync for every... I think mixing it in one stream is better, because that's what Rodeo does, right? That's what it does for us. It mixes everything. That's kind of the point of having this thing in there. So I guess, I mean, we can just handle this. We can just let it handle errors using this, right? And just use it as like a bag thing. We can do an async, like Tokyo spawn, and then we'll just do like an async move. And we stream here, stream. As you can see, it is clearly being referenced. And we just do a loop. Futures, you cannot be sent. Oh, because you can't set the stream. God dang it. Can we set this thing? Is the question. Straight send is not implemented for required by we're just gonna do it anyways. From noise 10. What's up, Presty? We're not making cocktails here. I hope you know that. Ja, jetzt kann man auch Deutsch reden, wenn hier niemand anders ist. Whatever. Digga. Weißt du, warum es diesen Stream gibt? Ja? Das ist einfach nur meine Motivation, am Voice Chat zu arbeiten, okay? Weil, ich sag's dir so, ja, ich habe absolut keinen Bock gehabt, heute Rust zu machen, ne? Und jetzt guck es dir an, ja? Jetzt guck es dir an. Ja? Wir sind hier am Playing Engine am machen. Ich habe vorhin den Jitter Buffer hier getestet und der funktioniert. Das ist crazy. Livestreaming hilft mir einfach, Digga, das ist jetzt mein Tool, damit ich mich auf Coden fokussieren kann und nicht auf irgendeine andere Scheiße. Nee, Content Boy nicht. Dieser Stream hier ist nur zur Motivationsfüllung da. Digga, mache ich jetzt wirklich einen neuen Output-Stream einfach. Yes, this is the way. This is dropped. Playback will end and attached. Output stream handle will no longer work. Wie kann man so ein Hundesohn sein? Nein, Digga, nein. Jetzt muss ich mir hier irgendwas überlegen. Ach, was ist das? Ich töte jetzt halt wieder doch eine Hard Mute X. Er kommt halt hier. Thank you, thank you. I don't really care about the view count, to be honest. As I said, the stream is just a tool for me to actually work on the project and not do any weird other shit. And that's been working very well so far. Because I've been working on this thing for like an hour. Upwards of an hour now. And yeah, whatever. Anyways. So we're just, I guess, I have to put an option around this stream handle. And it means here I have to expect this. Oh, I couldn't get upper stream. And then we'll wrap this in brackets, maybe? Frick. Oh wait, we need a mutable pointer. No, we don't. Okay. I should just be able to. Do this. Behind a mutable reference. I love the borrow checker. It's beautiful. Dude, you're an option. Do I really need a mutex around this thing now? If I unwrap. Just fix it, Copilot, please. Let's see what it does. As Rev. Oh. Yeah, that would make sense. I love it. A handle. Now we're we're just gonna need some kind of thing that actually does it. Okay. Now we're just gonna need something here that actually, like, makes this worth it. Which I don't think there is anything. But yeah. We're just gonna say, like, let engine, and we're gonna create a new one. And so this one's just gonna be like the client map, which is gonna be a new hash map. And then the output handle is just gonna be none. And then the stream is gonna be created in here. And now, because we're in an infinite loop in here, that's just gonna wait for 250 milliseconds maybe. We can now just turn engine down here. Now here we can do a little bit of trickery and just copy it. Let engine equals engine.clone. Clone. Oh, and yeah, this needs an arc and mutex. And now you just can be sent safely. Send is not implemented for, is required by RS 29. It's required by this block, dude, huh? What do you think I want to send, dude? I'm sending an option with none. Or like, I'm sending nothing. Am I? Huh? I'm not sending anything between threads. There's nothing. Huh? Why is creating the output engine in there a problem? It doesn't do anything. I'm not sending anything between fucking sessions, dude. Not a single thing. I'm just creating something new in here. What if we spawn a task? Yeah, this is not gonna work. Why does it have to be this way? Rust! I hate this freaking garbage language, dude. It sucks. Let's see what Copilot does. Because I don't think I'm doing anything wrong here. This just feels like a classic compiler issue. Okay, you just created it here. Dude, that's not what you're supposed to do. Like, wait, does it move the stream into there? If I call stream here. Yeah, no, it doesn't move it into there. Dude, then what's the point? That was the whole point of this. I guess we're gonna need a blocking task. Whatever. Yeah, this is what this is like, you know? I need to create this here. This is the last thread I'll use, probably. But for some things you just have to use threads, which is incredibly annoying. I would just like to have this in the async runtime, you know? But it just doesn't work. So what other is there left for me to do than just abandon it? Can't do anything about it, you know? You just have to sometimes use a normal thread. Oh no, that's not standard. Or not it either. Time. Sleep. Where does the time sleep method come from? Which time did I use? Core time. Oh wait, no, here it's thread sleep, right? Yeah. Well, yeah, we'll just sleep 100 maybe. You know, this is like just another one of those useless threads you just have to use because you're in Rust. Which is okay, but it's not ideal. But yeah, whatever. What can one do? Welcome to Rust. And then here we can also gonna have to use this. Get rid of the engine. Warning. And then that's gonna do that. I can add a target. We can do other crap. So now all I will have to do is, well, work on the other stuff. Like, we're gonna now need a new thread here for this client to be, well, able to receive audio. So we're gonna like add a timeout there. Then we're gonna append it to the sync. And for that, I'm gonna need this client to actually be, like I expected before, also arc mutext, which is kind of annoying. Wait, now we have a Tokyo mutex, and is this still, oh, okay, there's a Tokyo mutex, okay, good. So they do support this, which is nice. And then we're just gonna create the client in here. And then we're gonna change the hash map to the arc mutex of client. I did put one. Okay. It's nice. And then here we'll put the client. We'll clone it as well because we're gonna use it later. Borrow of move value ID. Oh. Better clone that here. And do I need to clone it now? Nope, I don't. Okay. And here, this is gonna, well, be an arc mutex. There's not gonna be a reference, right? Oh. Okay. Nice. So now, it's in the map. I guess we could add like a check here, but it doesn't really matter. Like if the output stream isn't registered, then what's the point of even doing this? And so if you guys, and this is like one of the weirdest pieces of code I've ever written. But I think we can like do handle stop and device changes here. Like we can in the future, we can just flick like a boolean and then we can handle like a lot of stuff in there. For now, we don't have like a stop for the engine because we don't need it. But like in the future, that's gonna be necessary when we're like working with, when we're like adding this to an actual code base. But for now, it should just be fine. So with that said, now we just need to add the packets to the jitter buffer, and then we should have like some kind of send function here maybe, and then that's gonna add it to the jitter buffer, and that will then hopefully work. So this thing basically gonna be our network queue, and then so the next thing to do is just play them. I don't think I would be saying this today, but yeah, I guess the library handles the like really difficult parts. Actually, before I forget this, we're gonna need to fix this in the encoder, because this thing currently just increments infinitely. But what it needs to also do is like if it hits the integer limit, we want it to wrap down back to 0. I forgot doing this earlier. So we're gonna do it like this. Or I don't know if the adding does it by default. Just go down, but I don't think it does. So we're just gonna do it here. Just to be safe. Because why not? And then in here we're gonna need a new Tokyo task. So we're gonna do Tokyo spawn. And then this is async move. And then in here, actually before I do that, we're gonna need a reference of the client. And and then this is gonna need, because we're gonna have 2 tasks here. And the first one, for this client, we're of course also like before we register the actual playback, we would like register a, well, basically something that would kind of register like a decoder, and that's gonna give us back audio packets. Actually, no, it's not gonna give us back audio packets. It's gonna give us back raw F32 vectors of audio. I mean, that sounds good. I'm just not sure if this is how, because it does have a sample rate, right? The thing. So we're gonna need some like decoded packet struct that we can slap in there instead. Yeah. Wait, then I don't even need the implementation I have here. Actually, let's just make this another one. We're just gonna say decoded packet. And then for decoded packet, and all this is gonna change is it's gonna be F32. This is the sample rate, this is the sequence number, and we don't need the ID anymore because we don't do anything with it. And then this is gonna be a receiver of decoded packet. And then in here in the closure, we can just say like, okay, let's like literally loop, and then we're gonna receive, so we're gonna say let, and then this is gonna require the receiver, so say let packet equals receiver dot receive, and then await, and I'm gonna say packet that is none. We're gonna return. Okay. Can I borrow receiver as mutable? Okay. Then we want this to take full ownership, so we're gonna put mute here. And And this can be moved in here, no problem, no problemo. And then we're gonna say we want the client. So we're gonna look that mutex and await it. And for that packet, we're just gonna add it to the client's jitter buffer. So client.buffer.push, and then, well, this isn't this decoded packet, and then we'll push the packet unwrap into there, and account board is mutable, so we're gonna say that is mutable, and then that's it for start a new task that adds all the packets to the jitter buffer. So this is gonna do all the adding. Okay, I was just about thinking like, where's the Star Wars music coming from? But it is in the no copyright playlist. That's good. Okay. So now, all we need is one more task, which is also gonna, actually, we don't need to copy here anymore because we've already cloned here, so we can just keep using the reference, I think. And all this is gonna do is basically, we're gonna also loop in here. For that, we're gonna create an interval, and that's gonna be time from Tokyo time interval, and we're gonna use our 20 seconds here, which is our default interval. We could like change this in the future, maybe. Also include other stuff, and then here this is gonna be an interval that tick away. Mismatch types. Huh? Why do you complain now? Oh, I didn't. Okay. Hello. Can I borrow interval? Okay. It's mutable, and then we can just literally like pop the jitter buffer and say packet equals. Well, first we're gonna have to look the mutex, of course. So we're gonna just copy this, and then this doesn't need to be mutable, I think. I'll probably need probably need C. And then I'm just gonna say client.buffer.pop. And this is supposed to give us this thing, yes, if packet is none. Oh, and yeah, this is where we also store the last packet, so we're gonna make a last packet here. It's gonna be an option and decoded packet. No, decoded packet. Because there's this thing in audio where there's like a couple of options you can have for what happens when like a packet is dropped. And this is like if packet is none, in this case here is when a packet is dropped. And in our case, what I've decided on is that we're just gonna like replay the last packet, which does sound like it's weird, or like does sound like it would be kind of stupid, but honestly, it is not all that bad. So there's also more modern approach. There are also more modern approaches, like using AI to like reconstruct those packets. But we're not gonna do anything advanced here because who cares? And like replaying the last packet sounds 10 times better than like, I've tried this with my old voice chat, this is why I know it, but the point is like replaying the old packet sounds like 10 times better than when you're just, you know, not doing anything. So we're just gonna check here, like if packet is none, and then we're gonna check if client.lastPacket is, well, if it is none, then we're just gonna continue because we can't really do anything about that, which is then unfortunate. But here we're always gonna set client.lastPacket equals packet. This is one of the most important things. And then we're just gonna say client dot, and then this is just gonna take in sync, and then we're just gonna like append And then here you create a new sample buffer. And now this directly takes in the sample rate, right? So this is cool. We don't have to like, it's gonna resample it automatically for us, I think. Or just use different ones. I don't care. When this works. So this thing takes in channels. We just have one. It takes in the sample rate, packet dot. Yeah, this is. Oh no! Now we have. So we're just gonna say, only packet is client the last packet, and we're gonna unwrap this because we know that it's something, right? Because we've checked it here. And then the packet has a sample rate, and it also has the actual packet. Nice. Can it move out of the reference of? Why? Okay, that's interesting. Why can't I unwrap this? Never had this before. Okay, okay. That's ref. We just need a reference. Yeah. Okay. Packet. If behind a shared reference as mute. Borrowed as immutable because it is also borrowed as mutable. Dude. This is less errors. These are less errors. Okay. Packet dot to as slice maybe. Okay. We can just convert it again. And then that works. Or could we just do like clone? Clone. Okay, that also works. I guess the cloning is always the best. But yeah, we're just gonna clone it. Maybe that's good. Maybe cloning's good. And so we're just gonna append it. It's like, okay, append that. Append the last packet when the packet is dropped. Add the receive packet to the Jira buffer. Just to make it like a little bit more clear, because I've been going kinda not that many on the comments here. But whatever, that's fine, I think. And then here, append the packet from the Jira buffer. And then we do something like this, and by this time, we don't need to clone it, I think. Oh, actually, we need to unwrap packet, so let's just do it like this. Let packet equals packet unwrap. Now that does it, but this copies it. Oh, right. In this case, wait, yeah, here we also we don't want to continue any further. That would be bad. Because then it's playing the thing anyways. Okay. That was close. So now, all that's left is done here. So this is some packet. Use of partially moved value, yeah, that was obvious. So we can just maybe... Oh yeah, right, it's not gonna really do anything. Let packet 2. And then here... some packet. Yeah, we're just gonna sync packet, whatever. It just needs to be copied so the sync can like take ownership of it. And actually, wait. If I clone the buffer here, do I still need this? Okay, just like... Okay. Yeah, then this is more performant. Set as the last packet played. Okay, that looks like it could work. We're also gonna say spawn a task for playing the packets at a consistent interval. And now that's our... I think... Dude, the music is very fitting right now, I'm telling you. Oh, I think it was so silent that you didn't even hear it. Whatever. Make it a little bit. It is the winning theme, you know? Because we are almost done. And we didn't even test it. I always say this and then end up regretting it, right? You know how this goes. But yeah, I think we should probably be fine. Because it only like starts playing when we actually have the receiver, right? Because this makes sure that it's not playing anything. Because then only if last packet is actually set, it will start playing, or if the jitter buffer like returns anything. And it'll also stop playing. This is actually quite nice, the way I did this. But yeah, this solves a lot of problems by default. And the jitter buffer is also really amazing. So yeah. Shout out to the one who made that library. That one's great. It just works and I don't have to do anything, which is... I always appreciate that. So... I would assume we can just literally go on and try this out if we wanted to. This is returning us the engine. We have everything we need, technically, to assemble a new demo that does all of the decoding and stuff using the code we just wrote. And that should now be way easier as well, I think. We're just gonna have to think of like a client ID. And to be honest, we can use this to also... Well, the engine's gonna need the encoding. Dude, we have four engines now. Because I don't know what to call them. But yeah. That should be fine. The decoding engine. Oh, wait. Decoding engine? Decoder? It's called decoding engine. Oh. Not public. There we go. Decoding engine. There we are. And now we will also have a... Well, we have an encoding and a decoding engine. We also have a playing engine. There are so many engines. I think a lot of engines are cool. They remind me of engines. And now I mean, I guess we're gonna need to change the decoder to actually return decoded packets. That would kind of make sense. But, and then this is also gonna have a playing engine. Alright, and that completes actually the entire project, dude. What the hell? I did this in 2 hours now, in a live stream. I'm gonna have to do more of those live streams. This is really, really efficient. I don't care that there's no chat. I don't freaking care, or I guess Presty is here. I don't know if he's still listening, but you get the point. But like, it's cool being able to finally achieve stuff again. Like, I would have probably not achieved this much if I wasn't streaming. But it's gonna be dinner soon, so my parents are probably gonna come in here again. So I need to be ready to press the magic button that just makes the camera disappear. Okay. So here's the voice listener. Got that all locked down. And then all this decoding nonsense. You know what? I'm gonna keep this around for now, because we might want to use some of this later maybe. So I'm gonna just throw this on here. I'm gonna say like decoding using manual decoding using demo of voice input and the decoding engine unused. Like, just here for maybe future, I don't know. The worst English as well. That's always how you gotta write those comments. Where is this? Okay. That makes the imports a lot cleaner. Now we have all the abstractions we actually need. So now technically we can just like go in. So the voice listener started and it would start encoding. And I guess we don't want to start it yet. I'm just gonna not start it yet, and I'm just gonna say here, let's spawn a start the. We don't need this. Get the sample rate. I don't even know if you need the sample rate here. Well, you should be fine by now, because the encoding engine has the sample rate anyways. Let's start the decoding engine. It's probably the next good step. So decoding engine. I don't know if this returns us anything else. I remember. Let's create. And what do you return us? A sender of audio packet. Sender. Let's see. We can actually make this thing a little bit simpler. I guess an unbounded channel is actually the best for this. So after this, start the playing engine. Playing engine, create. And so this should take in oh wait, it expects a receiver here. Oh! I'm freaking stupid. Yo, was geht's? Der Receiver ist jetzt natürlich nicht da, ne? Sondern der kommt woanders, der Schwanz. Ist eigentlich technically hier oben. Ja. Mhm. Mhm. Ich meine, wir können das auch immer noch ändern hier. Geht ja sowieso den Client. Wir können auch machen hier. Ja, komm, wir ändern das jetzt hier ab. Kein Bock, den Audioplayer zu ändern. Und dann fliegt er hier raus. Actually, wait, der braucht es doch. Fuck, nee, doch. Das können wir hier nicht ändern. Oh. Das heißt, ich muss das... hier unten wahrscheinlich ändern. Der gibt uns einen Receiver zurück. Ach so, nee. Ich bin bloß blöd. Da kommen die Packets vom Server rein. Natürlich. Okay. Okay, never mind. Alles gut. Okay. Wir haben doch nichts falsch gemacht. Ich bin bloß wieder zu blöd, meinen eigenen Code zu lesen. Bloß hier müssen die Decoded Packets jetzt rein. Und nicht mehr das alte Zeug. Hier muss jetzt... den Channel müssen wir jetzt verändern. Hier muss jetzt Decoded Pack... nein, das ist zu viel. Hier fliegt jetzt... da unten... Decoded Packet rein. Okay, und da kommt jetzt eine Menge mit. Okay, aber wir haben jetzt ja alles eigentlich, oder? Wenn wir oben data.sec sample rate, dann machen wir hier einfach decoded to back. Kommt jetzt halt auch noch mit rein. Okay. Und das funktioniert einfach. Keine Borrowing Issues. Perfekt. So, dann können wir den Decoding Engine hier auch mit reingeben. Und den Playing Engine, der kommt jetzt auch gleich. So, let Playing Engine. Das sollte mir nur den Engine zurückgeben, glaube ich, oder? Ja, perfekt. War gerade noch gemacht, das wusste ich noch. Das Match Type ist das eine Tokyo Mutex und hier benutzen wir eine normale Sync Mutex. Wir verändern mal alles zu den Tokyo Mutexes, weil die sind eigentlich viel cooler. So. Jetzt müssen wir es halt hier überall ändern. Egal. So, dann mache ich hier eine neue Mutex. Die nehmen wir aber nicht von da, sondern die nehmen wir von Tokyo. Dann mache ich hier den Blocking Block. Gibst du mir zurück Mutex Guard? Der lässt es einfach durch. Ohne. Achso, ja, klar. Ja, der Tokyo ist ja nicht inkompetent. So, Blocking Lock. Nochmal ein Blocking Lock. Nochmal ein Blocking Lock. Und nochmal ein Blocking Lock. Dann hoffen wir, das funktioniert einfach alles weiter so wie es soll. Dann haben wir das auch alles abgeschlossen. So. Hier kommt jetzt auch ein Blocking Lock hin. Und jetzt müssen wir den Encoding Engine verändern. Boah, es fühlt sich geil an, das gleich fertig zu haben hier. Wenn er gleich mal eine Demo hat, dass hier alles durch den Flow durchläuft, das wäre so cool. Keine normale Mutex mehr. Dann nehmen wir die von Tokyo. Nice. Und dann Blocking Lock. Blocking Lock. Und Decoding Engine brauchen wir noch. So. Wir sind fast am Ziel. Und ich höre... glaube ich. gucken. Bleiben mal so. Das könnte nämlich sein. Ja, Sekunde. So wie ich es mir gedacht habe. Ach mein Gott. Aber nicht hier reinspaziert. Das ist Progress. Anyways. So, wir machen das noch kurz fertig hier mit den Logs. Und dann, ja. Ach, die Sniffer used. Wait, was ist das? Da ein eigenes? Nee. Decoding Target hat's. Ja gut, das brauchen wir auch gar nicht. Wahrscheinlich. Dann unnecessary clone. Ja, hier. Aber für das brauchen wir es nicht. Wir können ja immer noch adden. Alright. Und jetzt hat der Engine hier. Jetzt haben wir die ganzen Engines. Nice. Jetzt müsste man hier noch irgendwelche Helper-Functions machen. Und dann haben wir es auch schon gut. Das hat sich super schnell angefühlt heute jetzt. Das waren 2 produktive Stunden. Anyways, man sieht sich mal wann anders. Vielleicht. Falls so irgendjemand im Stream ist gerade am Zuschauen oder so. Man sieht sich mal. Und weil ich muss jetzt Abendessen. I need to go to dinner now, so in case anyone English is in here, which I don't think anyone would be, but I'm just gonna switch to it real quick. Nope. Okay, then that will be the end of the stream. I shall see you sometime else. Maybe.